This is a video for the practice exam 5. For the first one is what is the resultant force of A and B in newtons? So for this, we just have R equals A plus B. So we need A and B. A equals 200 newtons. And we want the x component, so that would be sine of 60 degrees in the I direction, because this here would be the x component, so it's the opposite of that angle. And then the y would be this one or this one, so that would be cosine. So plus 200 newtons cosine 60 degrees J. So A equals 173.2 I plus 100 J. B is going to equal 500 newtons times, and we want the x component, so that'd be 4 over 5 in the I direction. And then the y is negative, so it's in the negative direction, it goes down. 3 over 5 times 500 newtons J. So that equals 400 I minus 300 J. That's newtons. The other one was newtons too. So now we just need to add them together. So R is going to equal just A plus B. So 173.2 I. That's that. And I'm going to go ahead and add the 400 J or 400 I plus 400 I. And then do the J's. So plus 100J minus 300J. That's just that last one there. So that's going to equal 573.2 I minus 200J. And that's newtons. So that's the answer to number 1. For the number 2, for F1, the x component of F1. So F1, the x component. So we want to go from F1, we want to start by moving down to here first. And so to get down to there, it's going to be F1. And then we know this angle is 50 degrees, so this is going to be the opposite of that, because it's also, this is what we're looking for. F1 times sine of 50 degrees. So that gets us down to here. And now we need to go over to the x coordinate. So we have that 25 degrees. So we're going to get over to here. Get over to right here. And that would be cosine of 25 degrees. It's cosine because that's adjacent to that angle. F1 equals 300 newtons. Yeah, 300 newtons. So that equals 300 newtons sine 50 cosine 25. So do it on calculator. We get 208.3 newtons. You determine the position vector is negative 6i minus 3j plus 8k. What is the unit vector? Express it in Cartesian vector form, so that just means the ijk. So the unit vector from C to D is going to equal that position vector from C to D divided by the length of that position vector from C to D. So that's going to be negative 6i minus 3j plus 8k. That's just that position vector that they gave us right here. That's in meters. And then divide it by that length of that position vector. So that's just 6 squared plus 3 squared plus 8 squared, all the square root of. And that's going to give us our unit vector. And our unit vector is just it just tells us the direction. The length is just 1. So I'll do a quick calculation. So that gives us negative 0.57. iPad's not working well. 75i minus, and then 3 divided by that. And I just calculated in my calculator, so I'm just pulling that every time. So 0.287j, and then plus, and then 8 divided by that length. 0.766k. And that has no units. So for this next one, so we set theta equal to 40 degrees, solve for TAB, provide the answer in pounds. So that angle is 40 degrees. I'm going to draw a free body diagram of that pulley. So we have TAB. We know this angle right here is 20 degrees. And then we have that weight, which is 100 pounds. And then this is all connected by that same cable. So that force F is also going to be 100 pounds. And then this angle is going to be 40 degrees. And so we're just looking for TAB. So we can sum the forces in the X or the Y direction. It doesn't really matter. Let's just sum the forces in the Y direction equals 0. And we're doing up is positive for Y. So we get to the Y would be, let's see, this is 20 degrees right there. So it'd be TAB cosine of 20 degrees. And that's in the positive Y direction. And then minus 100 pounds, and then minus 100 pounds. So the 100 pounds was this one first, and then the second one was 100 pounds, and then times that cosine of 40 degrees equals 0. So we get TAB is equal to 187.9 pounds. And if I had time to check it, because I solved everything quickly, I could also sum the forces in the X just to make sure I get the same thing. Let's see, we could sum the forces in the X direction equals 0, and that's going to equal negative, because we'll do right is positive, negative TAB. So that's just that 187.9 pounds. And for the X, that would be sine of 20. The 100 pound, one of the 100 pounds is just straight down, so that wouldn't be in the X direction. The other one is over here, And that'd be the positive x, 100, and then would be sine of 40 degrees, because we're looking for the piece that's opposite of that angle. Let's see if that comes out to 0. We're just checking. So 187.9 times sine of 20. And then 100 times sine of 40. And we get that equals, so it's negative 64.3 plus 64.3. That equals 0. So we're good. I just did a quick check using the other formula. For number 5, what is the moment of the 500 Newton force about 0.0 in Newton meters? Include the value and direction. So the moment about 0.0. So we have two components of that force. So we have this component, which would be 500 times 3 over 5. And then we have this component, which would be 500 times 4 over 5. This is the common triangles. But so, let's see, 500 times 3 over 5 would be 300. And 500 times 4 over 5 would equal 400. And so we have that distance is 1 meter. So if we look at this 300 Newton force, or the y component of that 500 Newton force, so moment about 0, and we're going to do our normal counterclockwise is positive. That equals, we have that 500 Newton force, and it's going down in this direction. So that's going to be in the positive direction, or we can do the right hand rule. And that's that 300 newtons times 1 meter, because we're perpendicular. So the 300 newtons times the 1 meter. So that creates a turning moment. And then the next one is this 400 Newton force, which is just the x component of that 500 Newton force. And that one is along this line, and it's 3 meters from there. And that one is going to be going in the negative direction, so minus 400 newtons. It's negative, you can see it goes in that direction, so that's in the clockwise direction, which will be negative. Minus 400 newtons times 3 meters. So that equals 300 Newton meters minus 1200 Newton meters. Equals negative 900 Newton meters. And it asks for clockwise or counterclockwise here. So we get that equals 900 Newton meters. And it's going to be in the negative direction, which is in that direction. And that's also clockwise. So 900 Newton meters clockwise. For number 6, it's one of those distributed loading ones. So I'm going to take 2 pieces of it. The first one will be the bottom one here. I'll call that 1. Or maybe I'll call it A, actually. And then I'll do the part B, which is the triangle. So we just want to know what the force of A, and or it's just the area under that rectangle. So 2 kilonewtons per meter times 6 meters. Sorry, that's my cat playing with a toy. That's 12 kilonewtons. And then the force of B, so we have it, it's going from 2 kilonewtons per meter up to 4. So that means this height right here is 2 kilonewtons per meter. And this is a triangle, so the area under it would be 1/2 times that 2 kilonewtons per meter times 3 meters. So that's going to give us is 3 kilonewtons. So the resultant force is just going to equal 12 kilonewtons. This one, we have the infant that weighs 18 pounds. So the weight equals 18 pounds. That length equals 1 meter. Determine the value of F2 required for the system to be in equilibrium. Hint, some of the moments about A equals 0. So I'm just going to start with some of the moments about A equals 0. So this is, oh, I guess I didn't have that labeled. This should have been A. And we could have done it from B. It doesn't really matter. So if we sum the moments about A, we have this force in the perpendicular distance. So that would be W, which is 18 pounds, times 3 times L, which is 1 meter, over 4. And that'll be in the negative direction because it's going to be clockwise. You see it's pulling down in that direction. And then F2 is going to be in the positive direction because it'll take us in that direction around A. So plus F2, and then times that distance, which is that whole distance, which is just 1 meter, equals 0. So F2 is going to equal 18 times 3 over 4 pounds. Oh, I made a mistake with this one. The 1 meter, it shouldn't have been 1 meter. It should have been in feet. But it actually maybe doesn't matter because 18 times 3/4 times 1 meter divided by 1 meter. So the length just cancels out. If it hadn't, we would have been in trouble because we would have had meters instead of feet. So F2 is going to be 18 times 3 over 4. So that's 13.5 pounds. For number 8, what is the force of member AE? Provide the answer in kilonewtons. Indicate whether it's in tension or compression. So use the free body diagram below for joint A to solve for member AE. So we're looking for this AE right there. So let's just sum the forces in the y direction equals 0. Because we don't know AB, so if we summed them in the x, we'd have an extra unknown. So in the y direction, we're going to get 3 over the square root of 13 times AE. And that's drawn in the positive direction, plus that 6 kilonewtons, this one here. And then AX is just 0, so it doesn't matter anyways. And AB is all in the x direction. That equals 0. So AE equals negative 6 square root of 13 over 3 kilonewtons. So that means I'd guessed the direction wrong. So 6 times square root of 13. We get negative 7.2 kilonewtons. So that tells us that AE is 7.2 kilonewtons in compression. Look back at the problem, make sure we answered what it was asking for. So it's provide the answer in kilonewtons. So we have kilonewtons. Indicate whether it's in tension or compression. So it's in compression. And use the free body diagram for joint A to solve for member AE. So that's what we did there. So there we go. Let's see, number 9. What is the force of member BC? Provide the answer in kilonewtons. Indicate whether it's in tension or in compression. Use the below free body diagram for the section of the left-hand side to solve for the member AE. So I've already solved part of it for you. So So we're looking for BC. So that's that one here. We also have some unknowns in it. We don't know EF, we don't know CF, but everything else, it looks like it's given to us. So we can sum the moments about this point F, since there are unknowns there. And then that should give us that BC. So sum the moments about F equals 0. And we'll do out of the board or counterclockwise is positive. So that equals, so I'm just going to move around it. So we'll start with this AX. So we see that's going to create a moment in that direction, in the negative. And then it's 5 kilonewtons times that perpendicular distance, which would be that 1.5 meters. And then that AY is also going to create a moment, so that goes up in this direction, which is also in the negative. So negative 10.42 kilonewtons, and then this perpendicular distance is 2 meters. You see, so this force times that distance. And then, so we've got, let's just maybe highlight with green the ones that we have. So we've, moment due to that one we've got, that one we've got. This one, the 10 kilonewton force is just in line with F, so it's not going to create a moment, so that's just 0. EF is in line with F, so that's not one. CF isn't going to create one, but BC will, so we need BC. BC is going to go in this direction. If we do the right-hand rule, it's positive, so plus BC, and then times that. So here's BC, and we want to do times that perpendicular distance of 1.5 meters. And that's going to equal 0 because we hit all the forces. Or actually, I didn't highlight the F1 either. So this 5 kilonewton force is also on F, so that doesn't create a moment. So now I just need to do my calculator to figure out what the solution is. My calculator is running low. Battery, state 5 times. So we get BC equals 18.9 kilonewtons, and then it was times meters and then divided by meters. So the meters cancel out. So it's 18.9 kilometers, kilonewtons. And we get a positive number, so what we had drawn on the drawing was correct, so it is in tension. So it equals 18.9 kilonewtons in tension. Hopefully my calculator makes it. And then for this last one, block A has a weight of 8 pounds. And block B has a weight of 6 pounds. They rest on a surface for which the coefficient of kinetic friction is 0.2, 0.2. If the spring has a stiffness of K is 20 pounds per feet, and it is compressed 0.2 feet. So that would be L minus L naught. Determine the acceleration of block A just after it's released. So we're interested in block A. We're going to do a free body diagram equal to our kinetic diagram. So we have our normal force, and then we'll have the weight, which is at 8 pounds. So the spring is compressed, so when the spring's released, it's actually going to move in this direction. So that means the force of friction is going to be opposite of that. So force of friction, which is going to equal that 0.2 times N. And then we also are going to have this force of the spring. Let's see. And because it's compressed, the force of the spring is going to push it in that direction. So force of the spring, which equals K times L minus L naught. And then that's going to equal the mass times the acceleration of block A. So sum of the forces in the y direction equals 0. That's just looking at these two diagrams. So we get negative 8 pounds plus N equals 0. So N equals 8 pounds. If we sum the forces in the x direction equals negative MAA, we get the force of friction, which is 0.2 times N, which is 8 pounds. And then we get minus that spring force, which is K, which was 20 pounds per feet, times the spring constant, which is 0.2 feet. Feet cancel out. The other N and the 8 pounds are both in the y direction, and that's going to equal negative, and the mass, the weight is 8 pounds, so W equals mg, so M equals W over G. The weight is 8 pounds, so 8 pounds divided by 32.2 feet per second squared times that acceleration of A. And so now I can, solve this. See if my calculator's still gonna work. Battery is very low, it's very angry with me. Let's see, 0.2 times 8 minus 20 times 0.2. And so we get that times negative 32.2 divided by 8. So we get A sub A equals 9.66. And that unit is, so we have pounds, we're on the left side, then times feet per second squared, and then we divided by pounds. So the pounds cancel out, so we end up getting 9.66 feet per second squared. And that's our answer for that.